Hello guys, you are welcome to my YouTube channel Mathematics Made Easy. So in today's video, we are observing one of the branch of mathematics, which is the abstract algebra. Some call it modern algebra. Alright. And then the topic we'll be looking into for today is binary operations. Binary operations. So before we explain what we call binary operations, we like to explain what we call rule of combinations. Rule of combination. Let me use red marker for that. Rule of combination. Now, what is the rule of combination? In mathematics, the rule of combination of two elements of a set S. Rule of combination of two elements of what? Set S is that what? May give rise to a third element which belongs to the set S. May give rise to the third element in what? In set S. Now, rule of combination of two elements of set S may give rise to the third element in set S. Now, let's say we are given set S equal A, comma B, comma C, comma D, comma E, comma F. Then we are to combine two elements from S. Let's say I want to combine A and B from set S. That is A asterisk B. Let's say this is the operation. Are you getting me now? So A asterisk B, the result must be one of the what? Of the member of S. That is the what? Third element. It's going to give rise to the third element, which is also in what? In set S. Let's say A asterisk B is equal to C. That is A, comma B, comma C are what? Are all elements of what? Of set S. That is rule of what? Rule of combination. And then we shall consider different rules of combination of elements of a given set. These rules of combination are usually called the binary operation. And take note, there will be some times that if you combine two elements in a given set, that the third element will not be the member of what? Of set S. So now we are going to observe what we call that what? That rule that combine two elements in a given set together to give rise to that what? To that third element, which is called the binary operations. Now, we have some operations that we all know. We use it every day. Your plus, your multiplication, your subtraction, and your division, they are all well-known what? Operations. Rule of combinations. Let's say you have A plus B is C. Okay? You can say A multiplied by C, A multiplied by B is equal to C. You can say A minus B is equal to C. You can say A divided by B is equal to C. That is what we call what? Rules of combination. Are you getting me now? These are the combination. A plus B, that is A is combining with B. But the operation here is what? Addition. The operation here is multiplication. The operation here is subtraction. The operation here is what? Division. But we have some advanced what? Advanced combination. So that is why we are looking into what we call what? The binary operation. Now, let's move on. Binary operations. A binary operation is any rule of combination of any two elements of a given non-empty set. Now, giving two elements A, comma B is an element of what? Given two elements A, comma B, an element of what? Set S. Now, the rules that combine these two elements together is called what? Is called binary operation. Binary operation. That is, we have A asterisk B to give us what? To give us C. And then where A, B, and C are all elements of what? They are all elements of S. So let's say we have this binary operation. Mathematically, we have binary operation. Let's say set S is mapping to set S to give us what? To give us some elements also in what? In set S. That's what we call binary operation. Is the rule that what? That combine what? Two elements in a given set to give us what? To give us another element in that what? In that set. So when we combine two elements together, the rules that combine those two elements together to give us another new element that is in what? That is in that set S. That rule is what we call the binary operations. Is what we call the binary operations. So most people usually use asterisk, can use asterisk, they use dots, triangle, circle, cross, circle, plus, and so on and so forth like that. Are you getting me now? So those are the what? Those are the rules, those are the combinations that we usually use in what? In binary operation. In binary operation. Now, let's look into the closure property. Closure property. Closure property. What is the closure property? A non-X set S is said to be closed under a binary operation asterisk if for all A, B is a member of what? Of S. That is, A asterisk B must also be a member of S. A non-empty set S is said to be closed if it's said to be closed under the operation asterisk if for all A, comma B is an element of S and A asterisk B is also an element of S. Then we said this combination here is what? Is closed under the operation asterisk. Is closed under the operation asterisk. Under the binary operation asterisk. So a non-empty set S is said to be closed under the operation asterisk if for all A be a member of S and A asterisk B is also a member of S. Now, the set of integers is closed under what? Under addition. Let's check. Set of integers. Set of integers is closed under addition. Now, we have set of integers which is dots, dot, dots. We have comma minus 3, comma minus 2, minus 1, 0, 1, 2, 3, 4, and so on and so forth. Now, let's take two elements from this set of numbers. Negative 3. We can take any two numbers, okay, from this set. Now, I want to check whether the set of integers is closed under the operation what? Under the operation addition. That is what we want to check. We want to check if set of integers is closed under the what? Under the operation addition. Now, let's say let A, comma B be an element of what? Of a set of integers. Then if you add any integers together, A plus B, that is, A is an integer, B is also an integer. So if you add any integers together, the result will always be a what? Be a set of what? Of integer. Are you getting me now? So if you take any number from the set of integer, if you add them together, the result will be a what? Be set of what? of integers. Now let's check. If our a is negative 3 and then our b is 1, let's check. Negative 3 plus 1 is going to give us what? Negative 2. And we can see that negative 2 is a what? Is a set of what? Integers. So that shows that the set of integers is closed under the operation what? Addition. You can take any number here. If you add them together, the result will be what? Will also be from what? From the set of integers. So that shows that what? Set of integer is closed under addition. Now let's check if the set of integers is closed under multiplication. Yes, it is closed under multiplication. If you take any integer a and b, then if you combine them together, if the operation is multiplication, a multiplied by b, the answer will be what? Set of integers. If an integer multiply an integer, the answer will always be what? Be integer. You can take any number as an example here. Now, let's check. Negative 3 multiplied by 2. This is going to give us what? Negative 6. So, negative 6 is a what? It's a set of integer. You are going to see negative 6 around here. So, negative 6 is what? It's a set of integer. So, if you take any integer here, you multiply it with another integer. So, the result will be a what? Set of integer. So, that shows that what? Set of integer is closed under multiplication. Now, let's check if the set of integer is closed under subtraction. Let's check that. Is set of integer closed under subtraction? Yeah, it should be closed. If you take any element from the set of integer a and b, then if you subtract it, a minus b will always be what? Sets of integer. Now, for instance, if you take negative 3, then minus negative 1, this is going to give us what? Negative 4. So negative 4 is a what? It's a set of integers. Are we following me? Then if you take another integer, you can take negative 2 and then negative 1. Negative 2 plus 1, this is going to give us negative 1, and negative 1 is also what? A set of integer. So that shows that the set of integer is closed under what? Under subtraction. But let's check if the set of integer is closed under division. Let's check that. Is set of integers closed under division? Let's check. Now, if you take a set of integer a over b, will all the results be set of integers? Will it? Now, let's check. If I take negative 3 over negative 2, this is going to give me 3 over 2. 3 over 2 is not what? It's not a set of integer. Okay? But 3 over 2 is what? Is a rational number. Are you getting me now? So, the set of integer is not closed under what? Under the operation division. The set of integer is not closed under the operation division. But the set of integer is closed under the operation addition, under the operation multiplication, under the operation division. But it's not closed under the operation, it's closed under the operation addition, subtraction, multiplication, but not closed under the operation division. Because when we take two elements from the set of integer, you take negative 3 and negative 2. When you divide it, 3 divided by 2, negative we get cancel negative, we have 3 over 2. And 3 over 2 is not a set of integer, but it's a what? It's a rational number. So division is not what set of integers is not closed under the operation division, but it's closed under addition, it's closed under multiplication, and it's closed under subtraction. So you can check for natural numbers, real numbers, okay? Check that as your exercise. Now let's look into some example. An operation asterisk is defined. Let's do this example. An operation asterisk is defined on the set of real number. an operation asterisk is defined on the set of real numbers. On the set of real numbers. Such that x, y is a member of R, then x asterisk y is equal to x plus y over 2. Now let's check if this is closed. If this is closed, let's check. Alright, so we want to check if the set of real number is closed under the operation asterisk. Good. What are we going to do if we want to check? Now, there are some questions here. Say determine the following. Determine the following. Roman figure 1. 3 asterisk 2. Roman figure 2. We have negative 5 asterisk 4. Roman figure 3. We have 7 asterisk 3. Roman figure 4. We have 1 over 2 asterisk 1 over 2. So we want to check whether all these are closed. Okay? Now, solution. Roman figure 1, we have 3 asterisk 2. So in this case, your x will be 3 and your y will be 2. Okay? So 3 asterisk 2 will be equal to 3 plus 2 over 2, which is what? 3 plus 2 is 5. Then we have 5 over 2. And 5 over 2 is what? Is a set of real number. Okay? So the set of real number is closed under the what? Under the operation asterisk. It is closed. It is closed. Alright, it is closed. Now let's check for the second one. The second question is negative 5 asterisk 4. Let's check if it is closed. So this will be negative 5 plus 4 over 2. So this will be negative 1 over 2. And negative 1 over 2 is a set of real number. So it is closed. Let's check for the third one, which is 7 asterisk 3. 7 asterisk 3. So this will be 7 plus 3 over 2. So this will be 10 over 2, which is 5. And 5 is a set of what? Real number. And the last one is 1 over 2 asterisk 1 over 2. So we have 1 over 2 asterisk 1 over 2. So this will be 1 over 2 plus 1 over 2 over 2, which is what? 1 over 2. So this is also what? Closed. Therefore, the set of real number is closed under the operation asterisk. It's closed under the operation asterisk. Alright, now let's look into another example. Another example. Now, here's the example. An operation asterisk is defined. An operation asterisk is defined on the set S. On the set S equal 0, 1, 2, 3, 4, 5 by x asterisk y equals x plus y minus xy. Then find the following. A 2 asterisk 5, B 0 asterisk 4, C 3 asterisk 1, and D we have 4 asterisk 5. Good. Now let's check whether this set S is closed under the operation asterisk. Alright. If we start with A, solution. We have A 2 asterisk 5. 2 asterisk 5, that is x is 2 and y is 5. So this will be 2 plus 5 minus 2 multiplied by 5. 2 plus 5, that is 7. Then 2 times 5, that is 10. 7 minus 10, which is negative 2. And you can see that negative 2 is not a set of s. So it is not closed. Okay? So the set S is not closed under the operation asterisk in this case. That is, when you take 2 combining with 5, it is not what? It is not closed. So S is not closed under the operation what? Asterisk when you take 2 and 5. Alright? So it's not closed. Let's check B. B, which is 0 asterisk 4. So X is 0, Y is 4, and the 0 times 4, so this will be 4. And then 4 is the set of what? The set of S. The set of S. So when X is 0 and Y is 4, then S is what? S is closed under the operation asterisk because 4 is a member of S. The third one, C, you have 3 asterisk 1, so that will be 3 plus 1 minus 3 times 1. So this will be 4 minus 3, which is 1. So 1 is a set of what? It's a set of S. So when X is 3 and Y is 1, then S is closed under the operation asterisk. But let's check for the last one. 4 asterisk 5. That will be 4 plus 5 minus 4 times 5. So that will be 9 minus 20, which is what? Negative 11. And then negative 11 is not a set. It's not a member of set S. So when X is 4 and Y is 5, then the operation S is not closed under the operation asterisk. That is what we call the closure property. The closure property. So that's what we call the closure property. Alright, but if you are given this set by this given combination rule, without all this, and you are asked to prove if S is closed under the operation asterisk, you have this rule, x asterisk y equals x plus y minus xy, and you have x equals 0, 1, 2, 3, 4, 5. I want to prove that is S closed under the operation asterisk. Now, how are you going to do this? Good. This is what you're going to do. So we can use our carry table. So here's our operation asterisk. We have 0, 1, 2, 3, 4, 5. Okay? Then we here also we have 0, 1, 2, 3, 4, 5. So you can take the you can combine them one by one. This we can start with 0 and 0. Okay? So 0 asterisk 0, 0 asterisk 0. So that would be 0 plus 0 minus 0. This is 0. So that one is closed. Okay? You move on. 0 and 1. So that would be 0 plus 1 minus 0 times 1, which is 1. That one is there. Then 0 and 2. That would be 0 plus 2 minus 0, which is 2. Then if you do that for 3, you have 3. That for 4, you have 4. You do that for 5, you have 5. You move to 1. 1 asterisk 0. That would be 1 plus 0 minus 1 times 0. You have what? You have 1. 1 asterisk 1. That would be 1 plus 1 minus 1 times 1, which is 2 minus 1, which is 1. You have 1. Okay? So 1 asterisk 1 will be 1. 1 plus 1 minus 1. So 1 plus 1 is 2. 2 minus 1 is 1. 1 asterisk 2. That would be 1 plus 2 minus 1 times 2. And that one is going to give us what? That one is going to give us 1 plus 2, which is 3, minus 1 times 2. 1 times 2 is 1. Is 2. So 3 minus 2 will give us 1. So we have 1. Then move to 1 asterisk 3. That will be 1 plus 3 minus 1 times 3. So 1 plus 3 is 4. 4 minus 3 will give us 1. So if you do that for 4, you have 1. You have 1. Because 4. 1 plus 4. That is 5. Then 5 minus 4 is 1. 5 plus 1, that is 6. 6 minus 5 is 1. Then let's do that for 2. 2 asterisk 0. 2 plus 0, that is 2. And 2 minus 0 is 2. Okay? We have 2. You do that for 1. 2 asterisk 1. 2 plus 1. That is 3 minus 2 times 1. 2 times 1 is 2. So 3 minus 2 is 1. You move to 2 asterisk 2. 2 plus 2 is 4 minus 2 times 2 is 4. You have 0. You move to 3. Okay? 2 plus 3 is 5. 2 times 3 is what? 6. 2 plus 3 is 5. 2 times 3 is 6. So 5 minus 6 is going to give us negative 1. Even you can stop here. You can stop here. You don't need to stress yourself again. Since negative 1 is not an element of set S, then you are going to conclude that therefore S is not closed under the operation asterisk. You don't need to further more. You don't need to further at all. Since we do 2 asterisk 3 and got minus 1, then that shows that S is not closed under the operation asterisk. So that's what we call what? The closure property. The closure property. Alright. Guys, so that will be the end of our today's class. So in our next video, we move to the next what? To the next property, which is the commutative property. So don't forget to subscribe to my channel, like my videos, and share. So if you like this kind of video, please comment. Thank you.